are generally categorized two broad categories. One is the informed search, another is the uninformed search. Okay. Sometimes people read it wrongly and say that uniform search because it looks like there's something, but it is not uniform, it is uninformed. Okay, so we have checked that. Now we are discussing on uninformed search, and under the uninformed search categories we have discussed two different searches. One was the BFS, another is the DFS, breadth first search and depth first search. So other than this breadth first and depth first search, we also have some more types of uninformed search like uniform cost search, then some modified version of DFS with iterative deepening, something like that. But why all those types of modifications are coming? To understand that, we have to realize the limitations or strengths or weaknesses of these two basic searches, because BFS and DFS are very old and widely used, but these algorithms are fundamentally understood whenever we learn about computer algorithms, but these algorithms are not actually applicable for practical scenarios or real life problem solving. The question is why. We will try to find the answer of that why in this session today. Okay, because until and unless we face any difficulty, we do not go for the modification. So obviously researchers or scientists have faced some difficulties and limitation among these algorithms, so that's why we are going for a complex one. So what was those difficulties or complexities? Now beforehand, yesterday I missed this, that how generally we evaluate that which search strategy is better. Suppose for a particular problem solving, I may have different search strategies or algorithms. Same problem. To solve the same problem, I may have algorithm 1, algorithm 2, algorithm 3, algorithm 4, and number of algorithms. But how should I decide that among those n number of algorithms available, which one should I choose? Which one should I select for my problem solving? So for that, some basic criteria is there that we have to understand or check or verify for those algorithms. So the first thing that we must check whether the algorithm is complete or not. That is the completeness checking. So what does this mean? It is written there. What is that? Yes, so if the solution exists in my environment, more specifically, if my goal state is present in my state space, then does the algorithm that I am using guarantees that it will find that goal? If yes, then I will say that the algorithm is or the strategy is complete. So whenever the strategy guarantees to find a solution, if one exists, obviously if the solution does not exist in the space, how can an algorithm find it? But if it is there, if I know the solution is there and my algorithm is able to find it, then we will say that my algorithm is complete. We will see that some strategies are there which always does not guarantee the solution. So in that case, those algorithms will not be complete. So the first criteria for selecting an algorithm will be to check whether my algorithm is complete or not. Clear? Clear? Good. Second is optimality. Already I have discussed about the concept optimality. Optimality means the low cost or minimal cost. See here, nowhere it is mentioned the lowest cost or minimum cost. It is said minimal. Again, the concept between the best and the optimum. Can you remember that I have discussed? So the algorithm, if my algorithm can find the solution in low cost or minimal cost. So in that case, I will say that the solution is optimal. Many algorithm or strategies can give you the solution, but not all are optimum solution because that may not match my desired criteria. The same example, like low cost solution, if I talk about, I have to reach to New Delhi from Durgapur, that I have given. One solution is also there. You can reach New Delhi without traveling in anything, just by walking. So that is also a solution, very lowest cost solution. But it is not a desired solution as well. Or also another solution can be you can hire a private jet and travel from New Delhi, Durgapur to New Delhi. So that is also a solution, but that is also not optimum. Are you getting? So I have to give a optimum based on some constant or criteria. Search cost. It is actually the derivation for the optimality that you are learning in probably in the data structure class, that we check the complexity of an algorithm into different ways, the time and the space complexity. Time complexity is a measure by which we decide that if the size of the problem grows, how the time taken by the algorithm to complete that or to finish that algorithm, how it will grow. That is actually known as the time complexity. Got my point? So it is not about actually the time taken by an algorithm. It is not the time complexity. Time complexity determines if the size of the problem grows, how the time that will be taken by the algorithm to complete, how it also grows. That relation. That is why you might have heard that all the time complexity symbolizations and all are given in the terms of B go up, N, B go up, A to the power N, B to the power N, something. So N is always there. N is what? N is generally the size of the problem. Clear? So this is one of the time complexity. So our always the desire will be to solve a problem in less time, as much as possible. So more or less time, or less time means more efficient according to our own perception, isn't it? So time is a biggest measure of an algorithm here. But not only a time, being an efficient computer engineer or a researcher or a student, whatever it is, whenever you will devise any new algorithm, you should always take care of the space. Though nowadays space is cheaper, but efficient programmer always think about space. Like while executing the algorithm, how much memory is being occupied or used. That measure is actually, what are you discussing? That measure is actually known as space complexity. So time and space complexity should be our measurement criteria. So these three properties we must check before we apply any algorithm to a problem. Clear? Now, in the previous class, I have discussed this breadth first search, how it works with the help of Q. Okay? Now, here we can see that basic key property, if I talk about completeness. So the BFS is complete. Why? If I say that breadth first search algorithm is complete, what does this mean? Can anyone tell me based on what I have said just now?
There is a solution in existence in that search area.
Now that is actually completeness you are talking about. I am talking about BFS is complete. So what does this mean? Hmm? It guarantees. Okay, make it take it. Speak it more formally. So this is where now you have the concept but you cannot express properly. This is the problem is taking place only because you are not going through books, you are not reading books, or also you are not writing. Earlier people or students used to have some kind of writing skills or reading skills. People used to write. Now the thing is that you have the concept. You know what is it. Whenever I ask you to tell it or write in more formally, clearly, you are failing. Only because you are not reading. Because the answers, how the answers are expressed, they are mostly written in textbooks. So that is why there is no alternative of textbooks generally. You can go through blogs, videos, but those are informal languages. But to formal languages, to understand the formal explanation of the problem, solution, definitions, or whatever it is, at least you should once go through the textbooks. You are all correct. And I am quite sure most of you understand what does this mean. But you should say that the breadth first algorithm is complete. It means that if solution exists in any search tree or any problem, then breadth first search guarantees that it will find the solution. Simple. Okay, so you should write or explain in this complete way. Your answer should also be complete, not the algorithm. Okay? So it is optimal, the question. It is written here, that doesn't mean. You have to ask yourself, is it optimal? Optimal means what? Remember, optimal means, does it give you the solution in low cost? So it depends. Obviously, it will vary, but cost doesn't mean worse. We'll try to understand. Obviously, we will check it in more detail. But one thing is for sure, as it is searching level wise, and it will continue till the last depth. So if solution is there at any node, it will find it. Eventually, it will find it. It may take a lot of time, but it will find it. Am I clear? So complete. Now check more about its properties in more depth and try to find out whether this algorithm is suitable for any real life problems or not. Okay, so all of you can remember this algorithm, or should I reiterate it? How the BFS work with the help of Q, I have discussed in my previous class, so I should not repeat this example. Should I? Yes or no? No. Good. Now take a case study. So suppose my model, consider a model of the search tree. We assume that every non-leaf node has B children. So suppose there is a node, this is my start node, and each node have how many children? B number of children. So here also. So when in a tree, each node has B number of children, what do you call that tree? Can anyone tell? I do not know whether it is written here or not. If written, you will be able to understand. What do you call that? It is called generally B-ary tree. It is called the ary tree of a tree. Okay, you might have not heard, but in data structure also you may read it in future. Huh? Binary is different. Binary is a tree where each and every node may have maximum 2 children. But if each and every node have 10 children, suppose each and every node should have 5 children. So that should be called a 5 arity, or arity of the tree is 5. Am I clear? So if this is the case, then what should be the number of node in the first one? What should be the number of nodes in the first level? If each and every node has b children, so here how many nodes? B number of. Then in the next, each of the b children is having, b node has having b children. So how many? B into b, that is b square. Then in the next, b cube. So in this way, in the depth d, what should be the number of children? B to the power d. If d is my depth, last depth. So if I add it, how much as per the formula? How much? This is a class 12 math. No. So it is what? This is the problem. Fundamental math is very weak. This is sum of I equals to 0 to d b to the power I. Is it or not? So how to get the result? It is b to the power d plus 1 minus 1 divided by b minus 1. সিরিজের অঙ্ক করনি তোমরা 12 এ? হ্যাঁ, এগুলো করনি? ভুলে গেছি। Or it is simply a GP series. Key. Then, okay, so I'm deviating from the actually. So one thing is very clear, that as my value of d will increase, my size will also increase of the tree, because d is in the exponent, so exponentially, so it is exponential growth depends fully on the value d. So that is why we can consider that the complexity of the algorithm is generally depends on the order of b to the power d. So now let us check what is that. Now you will say, sir, if it happens, so what? Okay, I have enough computational power, I can do it, so no problem with that. But if I take a simple case, suppose I have a search tree of depth 15. How much? Depth 15. So 15 depth का ट्री ज्यादा नहीं है क्या? अगर आप मानो, if I talk about air traffic routing, so how many routes are there? How many cities are there in the world? Can you remember? How many airports? It is more than 10,000 or something like that. 10,000 if I am not wrong. So in that case, I am only considering 15. Suppose the depth I am talking about. Now 15. Now each node, suppose have 10 children. So the arity of the tree is 10. So 10 array tree. So in that case, the total number of nodes will be 10 to the power 15. 1 plus b square plus bq. In this way it will, how much? b to the power 10 to the power 15 number of total approximately. Now BFS, now 10 to the power 15. After 1 there are 15 zeros. So if my BFS algorithm per second 10,000 node भी अगर वो सर्च करे, 10,000 node per second, 10,000 nodes, if it traverse, then it will take almost 3,500 years. It will take 3,500 years to traverse the whole tree. Are you getting? So 10 to the power 15 nodes or 1080 is not that much in relation to our real life complexity of the problem. But obviously you can understand, if my goal node is the last depth and last node, and if I have applied BFS, then I have to wait for 3,500 years to get the solution. Are you going to wait? Are you getting? So it is absurd. It is not feasible at all. So one thing you have understood very clearly, though it is complete, it is optimal also in many cases, but it is not feasible for real life problem solving. If it is a very small graph or toy problems, or just understanding with the help of pen and paper or a whiteboard, I can do it. But as my problem grows, as my problem become complex, more complex, then this algorithm simply fails. So this is its biggest problem. So though it guarantees solution, but its time and memory requirement. See, if each node uses 100 bytes, it will take 11,100 terabytes of space approximately, which is also very absurd. 11,100 terabytes for a simple one single algorithm. It's again a absurd one. So got my point? So these two are the limitations. Now the question, why we are moving towards the complex neural network or reinforcement learning or something like that. Why you didn't in the very first day didn't develop those things? Because we had initially started with some simple solution, some viable, feasible solution which could be solved by basic mathematics, simple steps, but all of them immediately failed when my problem became more complex in nature. So that's why we are going for evolutionary algorithms. Those are generally inspired by nature. And one of those nature or some human beings like our neuron. So from those neural network algorithm has come. So because those things are not there. Now again for the depth first search. So depth first search, though I have discussed the very basic principle in the previous class, you can understand. Now Ma'am has come. You just call na ma'am that that if you wish. Okay, wait. If anyone has ma'am's number, you just call her that we are waiting in the FF02. Sir is taking class at FF02. Okay. So DFS you have understood already. I don't have any problem. Like it will maintain a stack. So how the searching will take place? A, then B and C will come. But which one will be popped? B or C? If B then C, then which will be popped for DFS? B or C? If my stack is like this, so this is my initial part, so it is one way open, so it's a stack, so stack can be popped from the open end, isn't it? Last in, first out. So if B is first, C is then it will, C will be popped. So if C is popped, then how much? F and G will be pushed, then G will be popped, F will be popped. Simply these things will be, and whenever F will be popped, solution will be reached because F is my goal node. So just quickly check it. So if I give a C or B, either हम लोग पहले C or B or C दिया था. So if now push C at the beginning, B then now the B will be popped, no issues, and then E and D will come, and then D will be popped. E and D, that's no longer like that. After that C will be popped and G and A. Okay, whenever the goal state will find, it will stop it. So it's very simple. Now see the order in which I am inserting, based on that the steps is also depending. But either left pehle या फिर right pehle. But if when my problem becomes larger, then the importance of the selection also decreases gradually. But what is the advantage or disadvantage? Now, the one of the key advantage of DFS is its memory efficiency, because it is not searching width-wise, breadth-wise, so it is going to a single depth. Okay. Now it is not, other portion of the tree is not being stored in the memory. Only the path it is now traversing. Getting your point? So the memory use becomes very less. But the biggest problem is that it's not neither optimal nor complete. Complete in cases what? In many algorithm, many problems, my search tree is, depth of the search tree is infinite. Infinite means लीप नोड कहां पर है उसका कोई लिमिट नहीं है. दैट मीन्स बॉटम वाला खाली है, ओपन, मतलब इनफाइनाइट, यू कैन गो टू द एनी डेप्थ. Are you getting my point? So if in that case, if I follow DFS, got a point? Then what will happen? It will be in the infinite loop. It will not return. The simple thing is there. Suppose this tree is infinite, and my DFS starts from this path, and if this is my solution, DFS will not be able to find it, because it will follow this path, endless path, and go. Did you understand the main problem with depth first search? Yes or no? Anyone? All of you have understood, yes or no? So DFS does not work for tree with infinite depth, but DFS will easily find it because it is searching level wise. কি বলেছে ম্যাম? পড়ে গেছে? Okay, ঠিক আছে, I will leave it. No issue. So after this, you just go through this rest of the portion, because I will, here nothing is there, comparison between BFS and DFS is given regarding every component. It is very important. Already I have discussed, and also we have written when to use BFS and when to use DFS. Some interactive example also there in 8 puzzle problem and maze solver, how it will be shown, because search tree for these two is very big, so you cannot draw or understand it, but you can find it's working. So I have given here for BFS as well as DFS, so you can check it. Those who have already checked, okay, otherwise you will check it, that how the path finding is taking place. Like suppose the maze, S is my starting state and G is my goal state. So if I solve with BFS, it will generally follow this path, and if I solve with DFS, it will follow generally this path. So this is how the things will differ whenever it is BFS or DFS, something like that. You will check it. Okay. So any question or doubt? Turn off. Any question or doubt from today's discussion? So the concept of BFS, DFS clear. Their advantage.